G parameters, these are also called as a inverse hybrid parameters. These are also called as a inverse hybrid parameters. And the difference between G and H is previously what are dependent variables. Previously, what's the dependent variables? V1, I2, and independent is I1, V2 na. Simply inverse, ulta. Simply ulta. So now you take the dependent as I1, V2. So that is I1, V2 as a dependent. This is G11, G12, G21, G22, and then V1 and I2 as a independent. Simply ulta. Check it now here. This matrix will be simply ulta, isn't it? So what we can say, write this equation if we want. I1, which is given as what now here? I can write this equation. I1 is equal to G11 V1 plus G12 I2. Simply you can remember like this. V2 is equal to G21 V1 plus G22 I2. Right. As usual, what we can do here, we'll find these parameters now here. Now, what we can say these parameters now one by one here. So this is G11. Tell me G11, how to get G11 is I1 by V1 when I2 equal to 0 now. So then what are the units now here? Tell me what the units are. Mho. So what I should call this as a driving point. Same port now. Same port means driving point. Input admittance. Driving point input admittance. Next, G21. Tell me G21 is V2 by V1 when I2 equal to 0 now. Now tell me the units are here. No units now. No units. So tell me what I should call this as a voltage gain. What type of forward or reverse? This is forward voltage gain. Forward voltage gain. Next, G12. The G12 is a I1 by I2 when V1 equal to 0 now. And what the units are? No units. Units are no units. Now what I should call this as a reverse current gain. Reverse current gain. Next, G22. What I can say? G22, I am writing here G22, which is equal to V2 by I2 now when V1 equal to 0, and what the units are? ohms. Tell me what I can say this as a driving point. No, driving point output admittance. Driving point output admittance. Right. So these are the G parameters. Now we can develop the network also for this. So what I can say now, this is a KCL equation and this is a KVL equation. First one is KCL and the second one is KVL. So we can call it as what now? Input is a Norton's, output is a Thevenin. Now let us draw this network here. Norton's input is a Norton's and the output is a Thevenin. Now this is the port 1, this is the V1 and this is I1. This is the second port V2 and this is I2. Now tell me what I can say. This is G11. So see this thing. This sequence must be I1 is equal G11 V1 G12 I2. So yes, so this correct now here. This is G12 I2. This equation satisfied. Check it now. G11 V1 G12 V2. Now this equation satisfy here. So what I can say, this is G22, right. Next this is what now? G21 V1 voltage. G21 V1. Apply the KVL to this loop here. We'll get here. We can apply the KCL here. Then we'll get this equation. Right. Now let us see the further condition for symmetrical reciprocal. Here also the condition of symmetrical reciprocal, which is same for the like H parameters only. H matrix. What the H matrix now here? What the condition we have seen previously? Same analysis. Now if I can write simply delta G matrix, if it is equal to 1. So what I can call this as network is a symmetrical network. The network we can call this as a symmetrical. And what the other condition now here? If G12 equal to minus G21, then we can call it as a reciprocal. A reciprocal network. G12 equal to minus G21, it is called as a, if det is equal to 1, this is what is a det of G matrix. Right. Now here you can see this thing. Let us call if I call this as a something A matrix, which is equal to what I can say H into, let us call this a B matrix. Yes. So from this what I can say here, this is A matrix which is equal to H into B matrix. Na? So if I multiply both sides with H inverse pre-multiplication we are doing, H inverse into this is A matrix, and which is equal to what I can say this as a B matrix. H inverse. So from this, what I can say, this is B matrix, which is equal to what now here? H inverse into what? A matrix. You remember this, what is the A matrix we have taken? V1 I2, V1 I2. And the B matrix, what the B matrix we have taken? I1 V2. Check it. This thing now. Now see this thing here. If I replace them, so this B matrix, the B matrix here, it is a, this is I1 V2, and which is equal to what now here? This is H inverse. Yes, H inverse into what we have? A matrix means what? V1 I2, isn't it? You see carefully, this is nothing but this matrix. Want to check it now here? A. This is B here. This thing only now. Check it. This matrix and this matrix same. Now this is equal to this thing only now. This we used to write it as what we used to write here now here. I can simply write it as what now here? This is B matrix, which is equal to what I can say? G matrix into A matrix now. By comparing this thing, what I can say here? G matrix, which is equal to what now here? This is H inverse. And then G inverse from this. G inverse, which is equal to what? G inverse is equal to H. Vice versa. Right? This is a relationship between the G matrix and the H matrix.